Hello and a warm welcome back. Today on the other bench is a Tektronix 547 oscilloscope which I got some time ago, and I'm going to try and get it working. That's the plan anyway. It's quite a nifty little scope, 50, well I say little, it's rather a big scope. 50 megahertz, and it uses these 1A1, 1A2 etc. plugins. And it's, like I say, it's quite nifty because it's got two separate time bases, which means you can have two different waveforms on each channel with like different frequency waveforms. Usually, like say that the 545B, if I try to put like two frequencies in, you've got to be repetitive waveforms, so like sine wave, square wave or whatever, of different frequencies. It won't trigger properly. So yeah, so it's a bit like a dual beam scope. Bit different to the 545B, 585 etc, 585A, in that it's got these sort of weird up and down switches for the triggering, and that's the same, that's the A channel base, sorry, time base A, time base B, exactly the same. We've got a delay time multiplier, the same calibrator. You've seen the 1A1 plug-in before, that's the one I've fixed. And let's go and have a look around the side. It does, I'll get around to that another day. This is the, where are we, the right hand side, and as far as I know, all 500 series Tektronix scopes. On the right hand side is your vertical amplifier. You got your plug-in that goes into a vertical amplifier, blah blah blah. Up there, that drives the vertical plates. Up top, is your EHT section, pretty much the same on all 500 series scopes, I think. EHT transformer, that's driven by a 5AU6, and you've got an ECC8312AX7 regulator valve that keeps that 5AU6 in regulation. Very high voltage, something up to maybe 5,000, 8,000 volts positive, minus 1,800 volts negative. So if you don't know what you're doing or whatever, don't touch the buggers, because this will kill you, probably. If it don't kill you, it'll make you very unhappy. Right, let's spin round and have a look at the left hand side. Right, this is the left hand side of the scope. A little bit different to the 545B etc, in that all the other 500 sort of scopes have got like a little one sort of node nut bolt thing to move this. This is the A time base or B time base, I'm not sure, and actually B time base. This uses a lot of transistors, and we shall have fun with those later on. Also, the power supply section is pretty much the same as the 545B etc. However, it uses different valves. Still got a couple of 68s, and I'll get into the power supply a bit more later. Got a little bit of different sort of gubbins going off there. That's for time base switches. Let's have a look. And then we've got, the similar construction as on all 500 series scopes. Ceramic wafers, absolutely perfect workmanship. How the ladies who, put all these components in here got them as accurate as they did, with the straight leads and all the rest of it. Blimey, I really take my hat off to them, because whenever I work on them, it never goes back looking like that, no matter how hard I try. And every single joint is perfect. Every single damn joint is perfect, yeah. And I didn't really need another bloody 500 series scope, but I can't help myself. So I had 10 last year, and then I went down to 2. Now I'm back up to 4 again. But I just love these scopes. I mean, yeah, you've heard me wax lyrical about it before. So anyway, that's sort of a quick introduction. Onwards and upwards. Well, that should be onwards and upwards. That was onwards and sideways. Apologies. I'm filming this on wobble cam just to make it easy. Anyway, what I'm doing, I'm reforming the capacitors. Done this one here, 671. That's reformed really well, holding voltage, holding the charge. This other one, C701, it isn't, and I'll just point you to the McGubbins. So what we've got here, got my voltage doubler power supply, which is plugged into the variac, so I can, you know, control the voltage. That's going through one of my Fluke 25s, configured as an ammeter, and then we've got this other Fluke 25 here, reading. And we've got my other Fluke 25 here configured as a voltmeter. So I'm just gonna turn the voltage up. So as you can see, the current's going up and the voltage is going up very slowly. And as you see here, look at the current. We're already at nearly 1 milliamp. That's 940 microamps. That's too much. And I can just tell by the way it's acting. See, I'm turning the voltage up, and when I do, and then my little neon there, if you can see, it's flashing like a good one. So that's telling me that we've got a real high current leakage there. So usually what I do when I'm reforming these capacitors, I disconnect them from whatever they're disconnected to. But because this 547 is configured differently to all the other 500 series scopes I've worked on, where the other ones that I've worked on, you can get at the capacitors really easy. Like this, the rectifier board here is inside, it's somewhere else. This is a pain in the arse, this is. Anyway, I'm not happy with all the, you know, with a high leakage current there. Either the capacitor is knackered and then it's got to be disconnected anyway, or it's connected to something that is pulling current, and if it's whatever it's connected to is pulling current, then there's a chance I'm going to damage it by just like whacking loads more current into it. So I'm going to have to unsolder that big where do you call it here, sorry, I'm not very well at the moment. Got to unsolder this resistor here and disconnect it from whatever it's connected to. Try again and see what happens then. It's not normal. I mean, they shouldn't be leaking that much, but it's probably not been turned on for a long time, so this is what we're doing. We are reforming. So whatever it was connected to was pulling a load of current. So I need to really find out what that capacitor is connected to. I've been having a look at the 547 manual, and it's not as good as all the other 500 series scopes I've worked on, in that I can't find the bleeding C701 or whatever it is. I don't know where the hell it is, so unless I know what it connects to, then yeah, we're sort of guessing, aren't we? Anyway, onwards. Come on, focus, you bastard. Go on! Right, as you can see, the current's gone down, voltage has gone up, and I found where it is. It goes to the relay K601, and when that K601, after the time delay goes on, it connects to the center tap of those two windings. There's two windings on a transformer. They're the ones that usually bloody go on transformers, but anyway, it's not connected to anything at the moment, but so I can't see why it was pulling all that current. But let's whack some more voltage at it, and the current's gone down, so it probably just needed reforming. There's some beeping. I don't think it's me. Right, so yeah, I'm just going to go and sit down again. It's a 400 volt cap, so there's no danger of it going, you know, bang. Not pulling any current according to my neon there, so yeah, we'll leave it to do its thing and then come back in a bit. I've checked out all of the capacitors, the big caps, and you know, the power supply capacitors, and they all check out. I've reformed them all. Every one holds charge really well. One that I charged down here, with the two that are down here, which is C671 and C701, they both held a charge overnight, and yeah, they were still like over 100 volts on them the next morning. That one I had to take the leads off, and then I had to take some leads off another one. So the next thing I need to do is replace the is to take this old power, what do you call it, power lead socket thing. Need to take that off and replace it with a IEC one, cattle lead, because I haven't got one of those, unfortunately. So I have to do this to all my Tekscopes. However, I will keep it for future, you know, if a oscilloscope, somebody can put it on. One thing that I did find out is this capacitor here and this wire here goes to this BNC here, and it says mod vertical amp. So I'll have to look in the manual about that. I don't know what exactly they've done, whether it's just that cap or whatever. It just looks like that capacitor, but I know there are the same with all these Tekscopes. When they first come out, you get various revisions, so there's various things you can do to them to, you know, where they've made an improvement. So it's a bit like, you know, when you get a new bit of software, you get version 1.0, 1.2, 3, 4, 5, whatever, and then version 2. You know, sort of similar to that. Anyway, I'm going to go and change that IEC lead and then flip it up the right way, and then maybe power it up after one other thing that I'll need to do, but I'll tell you about it in a minute. Hopefully you can see in there we've got I've, you know, put the earth lead on. I just drilled a hole, put in a big 4mm bolt, and there we go. So while I'm at it, I need to, the phone's spinning okay, it's not seized up, but it isn't sort of free running. There is a little spot somewhere where you can put oil on, but I've forgotten where that is, and I can't find it this end, and I don't really want to. Getting these off is a nightmare, and yeah, I don't really want to take it off, but I may have to. That may be the proper way to go, because I can't see there's any way to get access underneath here. So yeah, I have to take that off. If that is, I have an Allen key that fits. That fits, but it's too sloppy. Come on now. There we go. Oh, you bugger. Right. I'll put some of my painted diesel and oil releasing mixture on that. So I don't want to strip those out, and then what I'll do, I shall give it a bit of heat, just so the oil sinks in. Oh, right, my thing's falling off. And that starts bubbling, I'll have another go at it. Right, let's have another go at that. Right, let's give that a go. Is that the right way? No, I'm going the wrong way, aren't I, you tit? It's this way. Oh, yeah. Kicky-handed today. Oh, there we go. That's gone. Hurrah! I know I've had them in the past where they are most reluctant to come off. There's not another one. Yeah, this one is still a bit reluctant. Might have to get a bit of a clonk, because that should have freed off by now. Let's give it a bit of a clonk. Only a gentle tap. Oh, let's try the other end, you ninny. Ah, yeah. Is that coming off? Is it buggery? Right, I think this is going to need some more releasing oil. Yeah, I was right, it is a swine to get off. Right, that's freed it up. What I did, I took out the grub screw, put some of my releasing oil in there, give it a little bit of heat. There we go. That's spinning alright, but I think it wants a bit of oil anyway, so instead of doing them bolts, there's 4 screws, rusty screws. A little clonk just to, what's it? There we go. Would you don't clonk some valves while I'm in there? I bet that's not going to do it. No. Yeah, like I say, they're real sods. That's why I usually leave them alone, because behind these screws it's not a bolt, it's a flathead screw. So, and of course we've got a couple of these soldered onto it. Oh, I know where they go there. Alright. Uno momento. Well, there it is out, and there are your 2 oiling points. One there and one there, but it's situated like that when it's upside down, so you could probably get in with like a curved spouty oily thing, but yeah, bit mucky, but we'll bung a bit of me homemade oil in there. It's basically just light oil. Not too much. Yeah, it's a bit of a jiggle to get. Yeah, that's better. Moving around a bit better now. Tiny little bit. Right. Just using that to clean it up. No really cleaning that up. I don't want to start chucking loads of water and soapy water at it. I'm not a real clean freak. I know a lot of guys who have this sort of gear really like cleaning things, but cleaning things is boring as, I think. Oh, you can't see, can you? Right, I shall endeavour to try and put it back in. So it's a bit of a bloody nightmare. So that goes in like that, doesn't it? Right, okay, it's spun right. And then these two leads come up through a grommet here and then solder onto a wafer. I bet if I put this on like this. Right, it's coming out now, isn't it? Right, that's wrong then, isn't it? Right, best do this off camera. To get the wires back through the grommet, got a bit of scrap wire, one end soldered. If I can find. So then what I'll do, straighten that out a bit. I've already got one through. Yes. Oh no, you bastard. Come back out, or has it? I don't know, not sure. Right, let's pull that. Yeah, nearly has. Let me go and retrieve the other one that's trying to sneak back through. Oh, you swine. Yeah, that's why I don't take the frigging things out. Right, that's got that. Oh, I just got it. Get that bloody well solder in a position where I can solder it right there. Yeah, you really need an octopus for this job. I tried doing it with tape, didn't work. That big. Right. Here we go. Right, that's come through. Just unsolder it now and then solder them back in. There we go. Alright, I don't know if I'll be able to get you to see this. Right, just there is where they solder onto. So I'm going to do that without you there because it's hard enough as it is. Right, back in. All of those bolts there are tightened up. So to tighten them up, these screws, I'm just going to do the reverse. Just get a little tap. There we go. And I've put a little notice in there, oiled February 2025. Yes, I could have shined them up on a wheel and everything, but can't be arsed. Still not feeling too hot, and yeah. If it goes, I don't know if it's going to go. It's got a tunnel diode in here. So, if the tunnel diode is knacking and I can't get one, then it's all a waste of bleeding time anyway. Right, oh no, of course it wouldn't. Everything is fiddly. Come on in your pop. This is great when you've got a dodgy back. Everything ups. Right. Come on, you duck. There we go. Still feels about the same, but once it's run for a few hours it should loosen up. Right, I need to sit down. That's the fan back in and the grill. There should be some foam there, but that's disintegrated a long time ago. So this is the time base and trigger in and all that over here, like as per normal on a lot of tech scopes. This slides open. Right, so that's the power supply. It's a little bit different to the other 500 series power supplies in that it uses EL86s instead of 12B4s. As you can see, there's a few big caps in there further up and a few valves at the top. This one has gone to where? This is a looks like a ECC 88 6DJ8. So I'll have to find one of them. Pretty sure that's what it is. It's got a lot more transistors in as well. A lot of them are rusty, which doesn't bode well, and they may cause us a problem because some of these suffer from tin whiskers, and I've just noticed something. Alright, this is going to be hard to do. Oh, for fuck's sake, everything's falling over. Alright, one moment. So I've just extracted this resistor because I noticed a different colour and it's got like some white matter. So before I fire up anything, sorry you can't see, I will test that. So let's go and find my leads and put this scope back on the bottom. Before we do that, let's have a look at these, what I think are the tunnel diodes. Down in here, this is, what is this? Should be a time base, surely. Time base A, I think. Alright, lean you over, find a point of something. Right, there's a lot of odd diodes. Where? Here, which you can't see. See these things? There and there, I think they are tunnel diodes. And they look a nightmare. I know you've got to watch when you put them in because too much heat and they die. They're basically very, very fragile things. A lot of gold wired diodes here. These look like RF signal diodes. When everything looks okay, it's just those tunnel diodes might give us jip, and transistors. But we won't know until we fire it up. This transistor tests okay. I've now got the unenviable task of trying to get it back in its socket, which is a nightmare because you're trying to do it upside down. Anyway, I'll do that off camera. forgot to press record. Right, over here got the vertical plate driver circuitry, and then a couple of valves, a few transistors. That's the vertical section, which runs off your plug-in just here. You know, it's an amplifier, basically push-pull amp. What we really need to do is get in here, because there are a few things that will stop one of these working. One is those tunnel diodes. Two is the capacitors, power supply capacitors, and three is this transformer, the HT transformer. It's not been powered up for ages, so I know I'm okay and I know what I'm doing. If you're ever uncomfortable with really high voltage, just leave it alone and get somebody to help you is familiar with working with it. So these diodes are 10 kilovolt diodes, and what happens with some of these EHT transformers, the insulation breaks down. So you'll power it up, you'll get a trace, and then the trace will disappear because the insulation is breaking down. What you can do to try and give them an easier time is replace these diodes with solid state ones, and to that end I just got 20, I think the RF 5000 something or other, 5 kilovolts, where do you call it, 5 kilovolt diodes off eBay, because I looked at quite a few places, and really high voltage diodes like 10 kilovolt, 15 kilovolt diodes are about 13, 14, 16 quid each, 20 quid each more. So I'm going to use a couple of those in series to replace each one of those, but first I want to test them. To do that I'm going to use my earmech. I can't remember what the hell it's called. It's a Type 5 or 251, I can't remember. It's an ionization tester. Can go from 1000 volts to 10,000 volts at various settings, and we can test things at a very high voltage. So I've got it set to 1k at the moment, 1 kilovolt, and I've got the diode reversed. So this is the positive on the cathode, the negative on the anode. In theory we should be able to whack that up and it will be fine. If it isn't fine, then they're no good. Right, just got to remember how to use this because it's been a while. Here we go. So if I point you at the see the meter, that's reading voltage at the moment, and that's fine. So let's bang it on 10k. And you see the needles going up. I'll zoom you in case you can't. I don't want to leave this on for too long because, you know, and I don't know what voltage is across there, so we'll just go about halfway and they seem to be fine. So the next thing to do is to put it on the 100 milliamp range, and then we can read off its resistance. And if I turn this volume up, you should hear any breakdown by clicking. Okay, that's fine. 10 milliamps. Just gives you a finer and finer. Okay, doke. Finer and finer calibrated reading. Ooh, let's not go too far there. Right, so let's say that's 5 kilovolts, and that is reading 2 watt. Where are we? We're on the 1 and we're on there. So 2 times 10,000. mega ohms, 20,000 mega ohms. Put it to that one and it's just jumped straight over. Right, and that's reading good. I'm going to go all the way over. That's reading, that's 10 kilovolts. So we've tested those, or tested one of them at 10 kilovolts. They're only rated for 5 kilovolts peak inverse voltage, which is the breakdown voltage of a diode. So now I've got to assemble, where are we, 10 of those, and replace the valve diodes, tube diodes that's in there, with a pair of these. Here we go then, see if it'll fire up. Fan's a bit slow. They always start a bit slow. Right, I didn't hear if it went click then. There we go, click. Alright. Intensity is right up. Focus, A-stig. Scale illumination works, don't usually bloody work. Trace separation, right, we've got nothing. Let's see what I've got there. Right, I can hear the fan. I'm going to keep an eye on that. Right, there we go, the fan's taking off. Can't see anything. Yeah, I've got nothing on the move. Oh, there we go. I've got one indication on the vertical, what's it, over here, but I've got no indication here on the horizontal. That's the horizontal position. No, nothing. So the next thing is turn it off, and then we're going to take some voltages from the power supply. Let me just turn it off at the mains. Feeling the fan, can't feel out. Right, so we've got no trace. So we need, yeah, got a bit of a smell coming off it, probably because it's warming up. So we need to find, this is different to all the other Tekscopes I've worked on, because it hasn't got the usual thing over here where you can take your voltages, power supply voltages. Right, nothing. Right, just turn you off a minute. Oh, here we are, I got them. So usually on Tech 500 series scopes, your power supply section where you take your voltages is there. On this one, it's over here. So let's turn you off, get me meter set up and have a look, and then we'll have a look at the EHT. Right, I powered it back up again, forgot to press bloody record again. Right, check your voltages, low voltage, minus 150 volts, bit high but it's there, plus 100 volts, yep, plus 225 volts, yep, and this one doesn't have a plus 500, this should be plus 350, yep. And we should have plus, no, that's it. So on a lot of other Tekscopes it's got a 500, but they have 500 volt rails. This one doesn't. So next we need to check that we've got EHT. Turn you off a minute and get my high voltage probe out. Here we go then. Here's my probe. Lovely probe. Let's have a probe. I've got my left hand behind me back in my pocket. Right, just got to figure out. I think this should be the minus, and I've got the bloody shakes. And we've got nothing there. Reading 0. Pretty damn sure that should be it. Let's check one of the other ones. Got my left hand right out the way. Reading bugger all. Check that one again. Sometimes these wafers you need to dig it in. Right, we've got no EHT, so that explains why we have no display. So what I'm going to do now is take this off. You can't see the meter. I'm going to take this off and I'm going to put my probe down there, being very very careful. So we should have 8,000 odd volts, you know, big bloody high voltage. I'll call it out. Oh, I've got the fucking shakes, and I'm getting absolutely sweet FA on there. Okie doke. So next we need to find out, let me just turn it off. Let me just remove my high voltage probe, and I'm going to move you. How this EHT section works is this. I'll tell you why we haven't got any fucking, oh, what did we, oh, pardon, that just slipped out. I'll show you why we haven't got any EHT. What a stupid twat. I'm not very well, so, and I'm also a divvy fucker. Right. See, just there, there's supposed to be a valve. Should have noticed that, shouldn't I? So I'm going to nip upstairs, find a 6U 5 something or other. I can't remember. I know what they are, but I can't remember. Back in a minute. Here we are. I've got two. I can't remember what the hell they're called again. Hold on. 6AU6. I've got two. This is a new one I bought a while back. Come on, you bugger. Yeah, I'll tell you how it works in a minute. Always a little. Right, that holds it in there. Ooh. Right. So this drives this transformer. It's a big pentode, single-ended, you know, single-ended thingy. It's like a single-ended amplifier, in other words, but in this case it's a single-ended oscillator. This oscillates at, I don't know, I can't remember, 43 kilohertz, something like that. It drives this, the primary of this transformer. The secondary obviously is, you know, kicks out loads of kilovolts. That's doubled in there, but with a load of capacitors, high voltage capacitors there and there, and underneath there there's a big doorknob one there, and through those diodes and capacitors you get voltage doublers, triplers. That's where we get a high voltage. So let us try once again. There we go again then, 2, 3, 4. I'll put my ooh, yeah. Okay, is it gonna be? Of course we can't see it. Fucking hell. Oh, you stupid bloody thing. So turn it off, Andy. Right, got to be quick so the battery's going. Right, as you can see, we've got it something. So we've got EHT, but I can't focus it. Well, I can. The intensity works, but it's just like, you know, it's just a bit stuck. Right, so obviously there's a lot more at fault, and we're just going to quickly test the EHT. Pointing at the thing. Right, got my left hand well out of the way. Right, I'm not reading anything there. Still not reading anything. Right, we've got no negative on the we've got no negative on, we've got no minus 1000 volts is what I'm trying to say. Right, and I'm getting, right, 3.5 kilovolts. So the EHT section is probably knackered. I need to look into this further. The battery's going. See you soon. Another quickie again. You can see this is the anode of the 6AU5, whatever it is. We've got a sine wave there, but it's really way too big, so there's no regulation. Right, another mistake of mine. One moment. Because I forgot to put another freaking valve in. It's missing the other one, the ECC 83. Tits. Really not with it today at all. Shouldn't be messing about with this when I'm in this state, but I mostly know what I'm doing. Next day now, we've got some progress. As you can see, we've got a little trace. So obviously something's wrong there, but at least I have got a focused trace. And the horizontal is all the way over to the right. So there's something wrong with the horizontal circuit, but I know where to start to look. So at the moment we're on channel 1, and as you can see the vertical is sort of working. Flick to right, and that's channel 2. That sort of starts to work. And we've got chop as well. That's on out. Right, okay. Yeah, I've got to do some reading. So yeah, and will that? Okay, one up there. Right, there's something wrong with the vertical as well, but at least we've got something, because all I had before was a blob. What have I done? Okay. I've changed those valve diodes out for those diodes that I mentioned yesterday. And the other thing I've done, I've just tacked in a 350 volt 10 microfarad capacitor, because that 270 ohm resistor was getting really hot, and the anode on the oh god, what is it, 5U6, what is it, 6U, no, 6AU5, sorry, I can never remember it. The anode on the 6AU5 was at 300 volts instead of 350 volts, but it should be. That capacitor's duff, so that was getting hot. At one point I fucked up, and I thought these were all 350 volt capacitors, but when I put that 250 volt one in, it vented, obviously because it's running over voltage. And something did start to smoke earlier on. It had been on for some time. I'm really hoping it isn't this. I had a feel of this. It's not getting particularly hot, so I'll keep an eye on that. So that's why I've got everything hanging out, which is obviously dodgy, because it's very tempting to rest your hand, which I've nearly done a few times, but you know. Right, so what did I do apart from changing them? I checked this switch here, which the vertical plug-in pushes that switch, and I think when that plug-in isn't in, it shorts pin 1 and 3, which is the output from the plug-in into the vertical amplifier here. It shorts those, so when you push it in, everything's cushy. There's another little switch down here as well. Yeah, another little switch down here as well. Clean that up. That is working. And then what I did, I took the voltages here. These are these pins. Oh, you fucking well can't see. These two connections here, they're your vertical plates, and then underneath you've got your horizontal plates. Now then, I bet you can't bloody see. A bit difficult to do. Right, those two wires from the horizontal plates come to, let me see, this valve here. Sorry, I keep getting snagged up. As you can't see, there's a valve here and there's two wires, and one is reading low. They should both be at about 350. I've got 246 on one and 45 on the other, so we've got a problem here. Whether that's the resistor or the valve, I don't know. So I'm going to have to go and try and find me ECC 88 6DJ8s, 6s or whatever the hell they're called, and I couldn't yesterday. So at least we've got progress of a sort, and it looks like both time bases are running, but like I say, there's just some problem with the horizontal amplifier. So I'll have a look at the valves and probably jiggle them about in the sockets. Try that first. If not, I'll try replacing them. Right, at the back there, these three valves are our horizontal output amplifier, the last few valves, and that is on the left hand side the V574, which is an ECC 88, and on this side we've got another ECC 88, that's V584, and then in the middle there was a 6197, and I've just popped in a known good 6CL6, which is pin compatible and more or less the same, just to see if that works. And while I was going through everything, I was just making sure all the transistors were seated, and I also checked this transistor. I checked those just in case, and this one, I bet I can't damn well find it. Right, let me just find my pincers. I noticed that this transistor, its leg was broken off, and this is it's got a tech part number 151108, I believe, and it's a 2N2501. I haven't got anything like that. Like an idiot, I got rid of all my old transistors I used to have, but I doubt I would have had one anyway. So what I've done for now, I've popped in a BC546, which is a bit higher voltage, but it's about the same frequency, and that one there and that one there are part of the trigger circuit. So, but that's really, least of my worries at the moment. The main thing I'm trying to get, is a full sweep. I mean, it's always the same with these bloody bases. I mean, some are alright, but yeah, probably gonna have to go through everything in the end anyway. But all I'm trying to do for now is just trying to get it up and running ish, then I can dive in deep, if you're with me. Well, that's not cured the problem. I didn't think it would, to be quite frank. I've tried just gently fiddling with the sweep length, so now I think what I need to do is to dive in and start taking some voltages on that output, horizontal output amplifier, because obviously the right hand side is low, as I mentioned. I've got bloody notes everywhere. Where are we? Stuff everywhere. Like I said, on one side, on the left hand side, there's something like 149, I don't know, 100, 200 volts, 250 volts. On the other side is 49 volts. And basically how the output section works, it's a bit like a long tailed pair. There's two triodes, the 6 DJ, whatever, the ECC88s, I can remember that easier. Two triodes, cathode sort of connected, cross connected to that 6CL6 61 whatever it was, 97. And obviously the first thing would be to do is to check the grids of each of those triodes, because, well, the grids and the power supply going into the anodes. So I'm going to do that first. Right, that is Q534, and as you can see, it's rather mucky. I have tested it and it tests good. And this is your input to the horizontal amplifier circuit. Right, I'm going to zoom you out again. You've seen the muckiness. I still can't talk very well. Stop drinking, you see. I used to drink loads of beer every day, and that was the only sort of thing keeping me sort of, I don't know, Frank knows. Don't know why I'm even telling you really. But anyway, so yeah, this transistor is your input to the horizontal amplifier, and the where do you call it, the horizontal control, where you can make it go, you know, from left to right, that connects to that. So I thought, right, we'll pull that out, have a look at that. Could it be that it's a bit kaput? It isn't, so that's one thing ruled out. Well, I've just killed another transistor. I hope you can see that. There's rust there going to the emitter pin, and I tried to wiggle it to make sure it was seated in its socket properly, and in this time, instead of one leg dropping off, two dropped off. I'll show you in the scope. I need to zoom you. Right, there we go. So that's the socket that it came out of. And if I look, you can see the screws are rusty, but I've noticed on a few of them the transistors are rusty too. It's another one of them 2N2501s, so I hope I'll be able to get some of them. I don't know as replacing it with a BC546 is a good idea. I'm going to have to ask the boffins. But yeah, I suggest if you have a, see these ones, these big chunky buggers, they seem to be alright because they're right down on to the base of the socket, and they don't seem to suffer from that as much as these. But because these are poking out, the gold leads are fine, but where they join the can at the top, that's problematic. And it probably would have tested okay, you know, I should have left it alone, but I thought, well, I'm here, you know, just give it a wiggle. Oh dear, legs dropped off. So really that stops play for now. But at least I've made some progress in that. Yesterday I didn't have a trace, and today I did. So there's still lots of work to be done, but hey ho. So I think with that in mind, because I'm absolutely about buggered anyway, we'll cut it there. So thank you all very much for watching me bumble about and, you know, make loads of stupid mistakes and things like that. But I'm not quite with it at the moment. I'm not, well, I never really am, but anyway, and you know, I get there in the end. Anywho, thank you very much for watching. Take care of yourselves. Yeah. Ta-ra for now. Wiggle wiggle.